This video is on modeling linear inequalities in one variable. First, we need to go over some vocabulary. You should copy all of on this page, so you may have to pause the video once I'm done explaining everything. We're going to use the following expression to help us define the terms below. The expression here is 4x squared minus 3x plus 8. The first word we're going to talk about is term, and in this example there are three terms. They are 4x squared, negative 3x, notice I included the minus as a negative in the term that follows it, and positive 8. Those are the three terms. The next vocabulary word we need to understand is coefficient. A coefficient is the number in front of, remember it's understood as being multiplied by, any variable. In this example, x squared has a coefficient of 4. 4 is the number in front of it, and it's understood to be multiplied to the x squared. Also, x, right here, has a coefficient of negative 3. I want you to get in the habit of treating any subtraction signs as a negative along with the term that follows it. It helps you not to lose negatives. A constant can be thought of as a plain number. It's a number that is not being multiplied by a variable. So in this example, positive 8 is the constant. It is possible for an expression not to have a constant. In other words, the expression could have just ended here at 4x squared minus 3x. And so it is possible, if you're asked to name the constant, that there is none, and that's what you would say. The last term is called factor, and we're talking about a factor here. Recall that when we multiply two or more terms, numbers or variables, the answer is called the product, right? The factors are the terms that are being multiplied to get that answer. So a factor times a factor is equal to the product. In this example, the first term right here, the 4x squared, has two factors. The factors, the pieces that are being multiplied, are the 4 and the x squared. The second term also has two factors. They are negative 3 and x. Those are the things being multiplied together in the second term. A lot of students forget that a coefficient in front of a variable is actually two separate pieces. You think of it as one piece together, but these are two factors, and together they make a term or a product. You try this one, 3x squared plus 4x minus 8y squared plus 6y. Answer the following questions. You can pause the video and take a look carefully. You may also want to rewind and look back at the last screen if you didn't get it all written down, because the answers there will help you to answer the question here. Okay, I hope that you've completed that. There are 4 terms in this problem. 1, 2, 3, 4. Each term, the first one is 3x squared. The second one is a positive 4x. I don't have to write the positive part because we never do. If it's positive, we leave it. We only write negatives. The third one is negative 8y squared. And the fourth one is 6y. It's positive. We don't have to write the plus. So first term, second term, third term, fourth term. You could be asked to name just one of these. The coefficients of each term. For the first term, it's 3. because that's what's in front of the variable, the x, in this case x squared. For the second term, the coefficient is 4 because that's what's in front of the x. For the third term, don't forget the negative. The third term's coefficient is -8, and the fourth term is +6. Now these are just the coefficients, the numbers in front of the variables. Is there a constant here? No, there is not. There is no plain number. Every term has a variable, and so this is a good example of an expression that does not contain a constant. The factors of the third term. The third term we saw was -8y squared. So the factors are the two things being multiplied. In this case, -8 and y squared. All right, before we go on to our inequalities, I need to remind you of some of the symbols that we'll use with inequalities. It's helpful to remember that the open part of the inequality symbol, the bigger part of it, the wider part of it, is always facing the bigger quantity. So this is a less than symbol. The next one is greater than. This is less than or equal to. And this is greater than or equal to. Now we're going to be working a lot with applications here, so it's important to recognize some words in the problem that will help you to know which symbol to use. If they use the phrase at least, that means greater than or equal to. If they use the term no more than in the sentence, it means less than or equal to. More than all by itself means greater than, and less than obviously means less than. So these again should be written down in your notes, and they will help you to translate the word problems into inequality statements. In this first example, I'm going to work through it with you together, and then you're going to do one where I'm going to give you a few hints to get started, and I'm going to want you to do it on your own. The second example we will go over in class together. So this first example, Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of the summer. He withdraws $25 each week for food, clothes, and movie tickets. And the goal is to write an inequality that represents his situation. Okay, that's an awful lot of information and certainly lots of words. I know that scares a lot of you off. The best way to start is to take your highlighter and highlight just the important things. So, at least keywords here. Also, the words at least tell you that this is going to be an inequality problem. So if you continue, highlight all the important things. The words at least in the problem are highlighted in blue because that helps us to recognize that this isn't going to have an equal sign. Since it's at least $200, it's going to be a greater than or equal to sign. Then we need to identify our variable. What don't we know? The question verifies that we don't know how many weeks. Okay, I think I cut off the question here, but that is the information that's missing. We know that he withdraws $25 each week. We don't know how many weeks he withdraws money, so that is the variable. So W is going to be the number of weeks, and you should always tell what your variable, whatever letter you pick, represents. Write your inequality. Okay, so 500 minus 25W is greater than or equal to 200. I know you're saying, how did you get that? So let's break it down. 500, that's what the amount that he started with at the beginning of the summer. And then since he withdrew money, we're using minus because money is coming off of that. He withdrew $25 each week, so it's 25 times W. 25 and W are factors of this term. 25 is the coefficient, actually negative 25, and W is the variable. The at least told us to do greater than or equal to because we want more than 200. And so we need this total to be greater than or equal to 200. The 200 goes on this side of the inequality symbol because this is what he has at the end of the summer. He wants to have at least $200 in the account by the end of the summer. Now you're going to learn how to solve these inequalities, but in this unit we're going to focus just on reading it, translating it, and setting it up. So look back over this if you need to really take it in, because now you're going to do one on your own. This example says the yellow cab taxi charges $1.75 flat rate and in addition to 65 cents per mile. 65 cents, make sure you use the decimal 0.65. Don't put 65 in a cent symbol. You can't do that in an equation. Katie has no more than $10 to spend on a ride. Okay, so what you're going to do is highlight everything, which is done here for you. That got you started. And the next step is to identify the variable. Look and see what you don't know. What you don't know is how many miles she went. And so that's going to be M, the number of miles. I'm going to let you finish this and we'll go over it in class. You should definitely write down what M is equal to, what it represents, and now the same exact way you did the last problem, use the keywords and the numbers given and write an inequality to represent this situation. Good luck, and I'll try it with you when you get back to class.